Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Alia Anisa and I am going to talk about computer networks. First, what is computer network? Computer network is a collection of computers and devices that are connected together using communication devices, for example, a modem or transmission media, a cable, or both. There are three types of computer network, which is LAN, MAN, and WAN. First, LAN. LAN stands for Local Area Network. It is a network of computers that are connected together in the same building. For example, an office. The devices and computers are close to each other and are connected using Ethernet cable. There is also another type of LAN, which is LAN. LAN stands for Wireless Local Area Network. It is basically the same as LAN, but it is wireless. It uses Wi-Fi, which is wireless fidelity, to connect the computers together. It also uses access point, AP, which is a base station that connects wireless devices to computers. For example, computers that connects with a wireless printer. The second computer network is Metropolitan Area Network. It is basically a cluster of LAN that connects together in the same geographical area. For example, several buildings in the same city or town that connects together. MAN basically is smaller than WAN, but it is bigger than LAN. The third and the last computer network is WAN, which is Wide Area Network. Wide Area Network is a large network that connects computer, whether it is from different state, country, or even different continents. The closest example for WAN is the internet. I think that it is all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Suhaila binti Jamilan. Today, we will discuss about network topology. Network topology is logical layout of wire and equipment. There are 5 types of network topology. First is bus, also called as a linear bus. One wire will connect all the nodes. The advantage of this network topology is easy to set up and small amount of wire. Disadvantage of this network topology is slow and also easy to crash. Second topology is star. All nodes are connected to one hub. A node will send a data to hub and hub will send a data to destination. The advantage of this topology is easy to set up and one cable cannot crash a network. Disadvantage of this network topology is one hub will crash entire network. The third topology is ring. All nodes are connected in a circle. Token is used to transmit the data. The nodes must wait for a token to send a data. The advantage of this topology is the time to send a data is known as they have a token. Disadvantage of this topology is a lot of wire is used and slow. Okay, for the fourth topology is mesh. All the nodes are connected. The example of this topology is internet. Internet use a mesh network topology. The advantage of this topology is data will always be delivered. Disadvantage is hard to set up and use a lot of cable. For the last topology is tree. hierarchical model that have 3 layers. 1. Core layer. 2. Distribution layer. And third is access layer. The advantage of this topology is scalable, easy to implementation, and easy to troubleshooting.
Hi, my name is Muhammad Aqil Irfan and I'm going to explain about QoS and basic distributing. QoS is basically a quality of services that refers to any technology that manages data traffic to reduce packet loss, latency, and jitter on the network. QoS control and manage network resources by setting priorities for specific type of data on the network. The most important parameters that affect QoS for multimedia data transmission is bandwidth, latency, packet loss or error, and sync skew. There are 3 levels of QoS that can be stated, which is application level. Specify those parameters related to the user requirement and expectation. Frame size, sample rate, image and audio clarity are some parameters of this level. The second one is system level QoS, which include operating system and CPU requirements such as processing time, CPU utilization, and media relation like synchronization. The third one is network level QoS, which defines communication requirements such as throughput, delay, jitter, loss, and reliability. Now, I'm going to explain about basic distributing. A distributed system is a network of autonomous computers that communicate with each other in order to achieve a goal. The computers in a distributed system are independent and do not physically share memory or processors. Computers in a distributed system can have different roles. The computer roles depend on the goal of the system and the computer's own hardware and software properties. The first is the client-server architecture and the second is the peer-to-peer architecture. The concept of client and server are powerful functional abstraction, which a server is simply a unit that provides a service possibly to multiple clients simultaneously, and a client is a unit that consumes the services. The clients do not need to know the details of how the service is provided or how the data are received, stored or calculated. The example is signal from input devices on a computer need to be generally available to programs running on computer. For peer-to-peer system, in some of peer-to-peer system, the job of maintaining the health of network is taken on by a set of specialized components. Such systems are not pure peer-to-peer system because they have different types of components that serve different functions. The components that supports a peer-to-peer network act like scaffolding. They help the network stay connected, they maintain information about the locations of different computers, and they help newcomers take place within their neighborhood. For example, Skype, the voice and video chat services, as example of data transfer application with a peer-to-peer architecture, which when two people on different computers are having a Skype conversation, their communication are broken up into a packets of ones and zeros transmitted through a peer-to-peer network. This network is composed of other people whose computer are signed into Skype, where each computer knows the location of a few other computers in neighborhood. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Muhammad Ramzi Amri and I want to explain about parallel computing. What is parallel computing? Parallel computing is a type of computing architecture in which several processes simultaneously execute multiple, smaller calculations broken down from an overall larger, complex problem. Parallel computing refers to the process of breaking down larger problems into smaller, independent, often similar parts that can be executed simultaneously by multiple processes, communicating via shared memory, the result of which are combined upon completion as part of an overall algorithm. The primary goal of parallel computing is to increase available computation power for faster application processing and problem solving. There are generally 4 types of parallel computing. First, bit level parallelism. Second is instruction level parallelism. Third is task parallelism. And fourth one is superword level parallelism. The example of implementation of parallel computing is NVIDIA. How NVIDIA using parallel computing? One of the first industry that saw a sea change thanks to the parallel processing, particularly the GPU for general computing revolution, was medical imaging. Today, a whole body of medical literature exists cataloging how the high computation and bandwidth lead to vast improvements in speed and definition for just about everything such as MRI, CT, X-ray, optical tomography and more. That's all for me. Thank you.